Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals, More Examples. In this presentation, we will be solving example problems related to radical functions. Let us look at an example. We want to evaluate this indefinite integral square root of x minus 1 over 2 square root of x dx. We have some radical terms in the given problem, in the given example problem. So we want to be able to convert the radical terms to exponential terms to be able to apply the process of integration. So to do that, we're going to simplify, or we're going to convert square root of x to an exponential term as shown here. Square root of x can be written as x to the power of half. This is one of the rules of converting the radical terms to exponential terms. So now that we have converted the radical terms to exponential terms, we can rewrite the given problem as follows: y is equal to integral x to the power of half dx minus integral 1 over 2 x to the power of half dx. So if I back up one step, you can see that we can write this term as y is equal to integral square root of x minus 1 over 2 square root of x dx, and that can be written as y is equal to integral x to the power of 1 half dx minus integral 1 over 2 x to the power of 1 half dx after converting the radical terms to exponential terms. Now that we have that information, we are looking for constant terms inside of the integration process, integration symbol here. So in the first term, we don't have any constant. So the first term can be written as is, y is equal to integral x to the power of 1 half dx. There's no change here. In the second term, 1 half is a constant. So we're going to pull out that 1 half outside of the integration process. So we're going to write the integration symbol, and then we're going to rewrite the denominator as a numerator. In the denominator, we have x to the power of 1 half. When we convert an exponential term which has a positive exponent in the denominator, we can bring it up to the numerator and then write it out as a negative exponent, as shown here. X to the power of 1 half can be written as x to the power of minus 1 half, as shown here, dx. So if we were to read out the whole term, it is minus 1 half integral x to the power of minus 1 half dx. So now we are ready to integrate each one of these functions separately, and when we do that, this is what it's going to come out as. We are using in the first and the second term, we are using the power rule, and then let me just pull up the power rule is as follows. And the power rule is stating that if we have integral x to the power of n dx, where x to the power of n is an exponential function, then the power rule on integration is stated as follows: x to the power of n plus 1 divided by n plus 1 plus c. That's the way we're going to use it, and therefore we're going to use that power rule process in simplifying these terms. So in here we have integral x to the power of 1 half dx. We can write that as x to the power of 1 half plus 1 divided by 1 half plus 1 minus 1 half is a constant, so we're not going to do anything with that. Integral x to the power of minus 1 half, we can apply the power rule here. We can write as x to the power of minus 1 half plus 1 divided by minus 1 half plus 1. And then when we use the process of integration, we always add a constant, which is the term c in here. So when we simplify it some more, x to the power of minus 1 half, x to the power of 1 half plus 1 converts to x to the power of 3 over 2 divided by 1 half plus 1 is 3 over 2 in the denominator, minus 1 half times x to the power of minus 1 half plus 1 converts to 1 half, And in the denominator, we have minus 1 half plus 1, which converts to 1 half plus c. We can simplify it some more. So in the denominator, we have 2 over 3. And when we bring it to the side of the expression, that converts to 2 over 3 times x to the power of 3 over 2 minus, in the denominator we have my 1 half. So when we bring it out, we can write it as 2 over 1. We already have 1 over 2 on the side, so we can write that as 2 over 2 x to the power of 1 half plus c. We can simplify it some more. So the first term, there is nothing changes here. 2 over 3 x to the power of 3 over 2 minus 2 over 2 simplifies to 1. So 1s are implied. We're not going to write the 1, but we have this term x to the power of half plus c. So 2 over 3 x to the power of 3 over 2 minus x to the power of 1 half plus c is our solution, where c is a constant of integration. So that's the way we're going to solve an indefinite integral involving radical terms. Let us look at another example. Let us see, we want to evaluate this example problem, which example this example problem which involves radical terms as well. So we want to evaluate this indefinite integral fourth root of x cubed plus 1 dx. So we're going to first convert the radical terms to exponential terms and then apply the process of integration. So fourth root of x cubed is what we need to, that is the radical term. We need to convert that into exponential terms. So what we are going to do here is we're going to take x cubed, which is the term inside the radical term, and whenever we have a radical term, we can convert that as an exponential term by raising the inside term to the power of 1 over 4. If it is 4 here, it is 1 over 4. So now we can simplify this some more. And one of the rules of exponents is telling us that if we have a term raised to the power of something, and if that whole thing is raised to another power, we can write the base term once and then multiply the powers. So in this case, the base term is x, and the power terms are 3 and then times 1 over 4. 3 times 1 over 4 is 3 over 4. So therefore, when we convert this fourth root of x cubed radical term, it converts to x to the power of 3 over 4 as an exponential term. So therefore, we can write the given function as y is equal to integral x to the power of 3 over 4 dx plus integral 1 dx. So we have now we are ready to apply the process of integration. We're going to integrate each term separately, and when we do that, we're going to write it out as follows. In the first term, integral x to the power of 3 over 4 dx, this is very similar to the power rule. Let me bring up the power rule one more time. So in the power rule, if we have integral x to the power of n, we're going to increase the power by 1, and in the denominator, we're going to write it out as the power plus the 1, like that. X to the power of n simplifies to x to the power of n plus 1 divided by n plus 1, like that. So let's go back to our example. So in here, we want to integrate x to the power of 3 over 4 dx. So x to the power of 3 over 4 plus 1 divided by 3 over 4 plus 1 plus integral 1 dx converts to x, plus we are always going to add a constant of integration c as shown here. So now let us simplify this some more. X to the power of 3 over 4 plus 1, when we simplify that simplifies to x to the power of 7 over 4 as shown here. 3 over 4 plus 1 in the denominator, when we simplify that converts to 7 over 4, like that, plus x plus c. So 7 over 4 is 7 over 4 is on the side. So we're going to bring it to the side of the expression. So that converts to 4 over 7 x to the power of 7 over 4 plus x plus c, where c is a constant of integration. So this is how we're going to um, solve these integration problems involving radical terms. In my next video presentation, we will be solving more examples involving indefinite integrals.